My name's Chad, here with Quinn Poltz, owner of 74 Weld. Today we're talking about Bronco steering racks.
Yeah, so we'll just dive straight into it. 2.0 racks, this is kind of what your vehicle is going to come with. This is the Haas 3.0 that everybody's speculating on, talking about. We'll dive into that later. Right off the bat, there's several different configurations of what we're going to call the 2.0 rack. For all intents and purposes, while there's different programming and each model is not necessarily interchangeable with a different one because they're specific to that vehicle, they're all going to feature the same components, and what we're seeing is similar failures. Before we dive in too much on this, I want to make a clear statement. There's nothing wrong with the factory rack if you're using it in the method that Ford intended it to be used. If you're driving on the road or you're driving it down a dirt road, mild off-roading, factory configuration, stock tires, I think the factory rack is fine. I'm not going to go out and tell everybody that they immediately have to change their components. If you plan on putting on big tires, heading into rocks, doing stuff where we are seeing failures, our goal today is to discuss what the failures are and, in our opinion, why they're happening, and we might have time to touch on what we're looking at, but let's focus on the 2.0 stuff first.
Well, clearly we have broken racks here.
Yeah.
So let's talk about why they're breaking.
Okay, so I think to best understand why they're breaking, we need to take a massive step back and talk about the materials that are being used. Now, we haven't done a full material analysis on this, but I'm going to give you a little bit of general information about a cast aluminum product. So feel free to correct me on this, but typical castings, your transmission housings, that kind of stuff, one of the most commonly used materials is A356 aluminum. Now, A356 is a pretty good quality. It's used in tons of automotive applications. It has a tensile strength of 34 KSI and a yield of about 24 KSI. To put that in perspective, comparing that to 6061 aluminum, you're at 45 KSI and 40 KSI respectively. Now, that is how much pressure, that's basically where the material yields and where the material fails. What that does not necessarily take into account, and let's talk about, and this is, I think, the most critical component of this, is a concept called elongation. And when you're talking materials, elongation is the elasticity of a material. So that is how much that material can bend before it breaks. Anything under 7% is considered an inelastic material. Glass is a prime example. Glass doesn't necessarily bend, it shatters. A cast A356 aluminum has an elasticity of 3.5%. So that means it can bend 3.5% before it yields and before it basically fractures. So that's what we're seeing here is chunks falling off. That's typically coming from a shock load. To compare that to, say, 6061 aluminum, that has an elongation property of 17%. That is a huge difference when you're talking material composition. So keep those numbers in mind, but let's dive into failures a little bit more.
Why is this end here breaking? We see this end blown apart.
This is obviously the visible end of things. You can see it fracturing here. This side actually, in our assessment, appears to be just as common, if not more. And I should preface this. So these racks all have come from Lauren Healy and Von Gittin. As they break stuff, they're sending it. they're doing some testing, and they're probably doing stuff that maybe most of you won't do, but for those that are, know that we have good guinea pigs on this stuff. So
they're wildly abusive on everything they use.
They are. So you'll see a fracture that starts and it looks like it propagates all the way around. On this side, this piece used to be significantly taller and it's completely broken off. Now, inside of that is this support unit. What you will see here is this is an actual plain bearing, much like a rod bearing on a motor. This bearing will sit on the back side of this, and this physically would slide in here. This is your only support on the back side of that pinion, keeping the rack in line. So that's a half support. And without getting into crazy details, we beat this arc off on a CMM and compared it to this bar on a CMM. They are slightly different diameters. I understand why that is, but I'm going to tell you that this on this only touches right here and right there. That's it. Now, again, for road applications, it makes perfect sense and it's totally fine. When you get into heavy off-road loads, what you're gonna have, I don't know if you can see this on the video, but you're gonna have a rack bar that is supported halfway around. So if you load that, if you load it straight in this direction, you have the ability to blow it straight out of the housing, partly because of that 3.5% elongation property of a cast aluminum. If you load it the other direction, which you can do, and typically you're going to break these racks not driving down a dirt road. You're going to break them when you get into a rock garden and you're trying to crank the wheel and it's fighting you, and what happens is the motor puts enough torque through there that it loads it wrong and you'll drop onto the wheel and this will shatter or this will shatter or something will fracture. So we're actually seeing this side break more than this side. And sometimes when you see a failure like this, it's hard to know exactly where it starts. There's actually a whole part of material science that looks at how things fracture. There's people with PhDs in this. I'm not one of them, but you do learn a lot from failures. So we're seeing this consistently over and over again, and then I guess this is a good transition to talk into the bushings. So you might think, okay, well, it's fine. I'm going to go ahead and just press a tight bushing in on this. Don't do it. And the reason I say don't do it is this. So you have this is an angular contact bearing on this side. On this side, you have this plain bearing that is adjustable, okay? Keyword there is adjustable. So we put the Haas 3.0 housing up on our CMM, checked for bore diameter location on this side where this bearing rides, came over to the other side, came in with a long probe and checked this surface here in concentricity, meaning how close are the circles to one another, and they were out by roughly 30 thousandths of an inch. Now, that might not seem a lot if there are any engineers out there. If you have concentricity of plus or minus 15 thou, we'll be generous on that, that's kind of a lot. If you put a tight bushing on both sides, but one side is out of concentricity by 30 thou, what you are essentially doing is now forcing the rack housing into a shape that it doesn't want to be in. Remember how we talked about that 3.5% elongation property? You are now bending your rack, making it conform to a bushing that it's not supposed to be there, because this is supposed to be your only guide. So if you tighten up the bushings, in my opinion, it's not a good idea. I don't see that as a long-term solution. Again, it's just my opinion on this stuff, but we did do a lot of reverse engineering, and we see this point as a failure on pretty much every housing that we have. On one of them, they didn't actually know that it cracked off because it sheared so clean. We didn't catch that until we disassembled everything, and I went, and this part basically could fall out. If this falls out while you're driving, you now no longer have any preload on your pinion gear in relation to the rack. So this can come out, skip, break teeth, and you can lose all steering altogether. So a failure on either side is pretty much catastrophic.
It's good on the 2.0 racks.
Yeah.
Now let's compare it to the new Haas 3.0 rack.
Okay. So the 3.0, right off the bat, you see additional ribbing cast into it. It looks beefier. It is. The casting on it is significantly better. Let me take a quick step back and talk about castings in general. When you cast a product, what you're essentially doing is starting with nothing and adding material. When we machine a product, we're starting with material and trying to remove material. So one, you're starting with a solid chunk and machining away what you don't want. With casting, you're starting with 0 and dumping in what you do want. So all of these little facets and pockets and all that stuff, it makes sense on a cast part. Ford definitely improved with ribbing through here. I have, okay, so this is the opposite side on the 3.0 rack versus the 2.0. You'll see more ribbing. Now, the larger bore that sticks out between these two, that's just for a boot. So that doesn't really add any strength. The bushing that goes in here is loose on the rack. So that bushing doesn't actually support the rack bar itself. So the casting on this, it's better. Everything on the 3.0 really is better. With the exception of, let's be real clear about this, the internals of the 3.0. This is your rack bar here, 3.0, 2.0. They are identical. The pinions are identical. But we tested hardness of these. This is a pretty decent product. I don't see these, as of right now, I don't see this as a massive failure point. And I also think that electric assist on this is a pretty cool idea.
Can you compare that to a hydro assist?
Yeah. Oh, well, no, not in a short period of time. What I can tell you is Tesla semi-trucks are going to be an electric assist. Just because it's electric assist versus hydraulic. Hydraulic is not necessarily better than electric. Electric can put out way more torque and way more power than a hydraulic setup. That's entirely dependent on how the systems are sized. So don't think that hydraulic puts out more than electric. That's a function of the pump, what PSI it's running at. There's all kinds of stuff that goes into that. Electric systems can be super robust. So can hydraulic. It just depends on how they're designed. So with regards to, I think we covered internals, right?
Yeah, belt size, the pulleys here.
Belt size, the same. Pulleys, the same.
The motor.
Okay, so I don't have the Haas 3.0 motor because we're looking into, we have a systems engineer that's working with us, trying to get into some of the programming side of things to see if we might be able to up the torque output of the 3.0 motor.
But comparative to the 2.0 motor,
the 3.0 motor is bigger.
A larger motor.
So Ford touts that it's
30%,
33%, something like that. Is for sure is more torque, which is why they had to beef up this housing, because if you put 30% more torque through this housing, it's just going to fail quicker in those scenarios. So everything that OEMs do, they typically do for a reason. And I will tell you, as a general blanket statement, OEMs are so much better nowadays in off-road stuff than they were 10 years ago. It's just, automobiles have come so far, and I mean the Bronco's a testament to that. I think the Bronco's a rad vehicle. It's a great platform. But 3.0 versus 2.0 and comparing where we're at, again, internals are going to be the same, housings are going to be different, and motors are going to be different. What else are we missing?
Can you mount the 3.0 across all platforms? Is it going to be a bolt-in application?
Yes, you will be able to bolt the Haas 3.0 into any Bronco as long as you have the Ford Performance tuner, so you can flash it and you can tell it you're running the Haas 3.0 rack. There's been a bunch of speculation on this. Ford's working out all of these details and releasing that to us so we can put this rack in any Bronco and up your torque. And essentially that's really all you're doing, is you're upping your torque. Now, the Haas 3.0 will come with a larger tie rod, slightly beefier, because tie rods seem to be the weak point, which again, don't talk trash about Ford for this. They designed the tie rod to be the weak point. You have to have a fail somewhere in the system. They'd rather not have this shatter. They'd rather have a tie rod bend. It's safer. If you're going to have a failure, it's about risk mitigation. If you're going to have a failure, put your failure somewhere where you don't lose all steering and, well, never really want a tie rod to break, period.
No.
But tie rods are going to be a fail point.
It's also an easily replaceable part compared to a
Easily replaceable.
When it comes to new replacing racks and stuff, what about lights on the dash? Like, what causes lights? Why?
Okay.
Can you get away from it? Like, what's...
Good topic. So, is this about all the chatter that we see online about people speculating of what we are or are not doing? We're not going to, as of right now, we have no plans on making a hydraulic replacement dump-in rack. So, the motor on this whole setup is an electric motor. That has multiple plugs in it. That talks to a CAN bus system. If you unplug the factory rack and go to, let's say, like a PSC hydraulic kit, your dash is going to be a Christmas tree. And that is not something that you're going to easily solve. You are not going to, currently, and I can be proven wrong on this, but currently, you're not going to put anything but the factory 3.0, 2.0 rack in it and have ABS compatibility. So this has to talk to a CAN bus module, which is integrated into the factory ABS system. If you try to bypass that, you can. The vehicle will still run, but every light will be on your dash, and I don't really see that as a viable product. I don't think anybody, if you're fine with all the lights on your dash, then do whatever you want and put a full hydraulic rack in the thing and parts off a tractor for all I care. Honestly, if you just spent money on a brand new Bronco, are you going to be cool with lights on your dash?
No.
I don't think so. So let's be clear. What we're talking about is a product that has to be compatible with factory ABS modules and integrate into factory wiring. So no, we're not going to do a hydraulic rack. It'll be electric assist.
So that's a lot about these racks in particular. So 2.0, 3.0, like I said, the difference is 33% stronger from Ford, same internals.
Stronger, yes, but it's really more torque.
Yeah.
So because you're putting more torque through it, you have to beef stuff up. Now, typically, I can't speak for an OEM, but if you're going to make it 30% stronger, you have to at least make the housing 30% stronger. But what you're not going to do is you're not going to change elongation properties on a cast product. This is a glass product. It will break. You can't shock load it. And when you're in rocks and you drop a tire into a hole and you try to wedge your tire over, you're shock loading the whole system. So this is perfectly fine for mild off-road use, on the street, no issues, larger tires, 35s. Ford is going to package protect for a 35 with this. Can you get away with 37s? Probably, yeah. Because when they package protect for something, it's a fancy term for over-engineering. So can you run 37s with it? Yeah, probably. Can you run 37s in the rocks with it? I don't know. That's your call.
You'll find out.
Yeah.
So moving to a different material, say maybe 6061.
Yeah. So we have a full billet aluminum rack in the works. I actually saw material start moving through the machine shop today. We will be making a full replacement rack. It will be compatible with all of your electronic systems. It will talk to Ford CAN bus. It will use the factory Ford motor or the Bronco 3.0, the Haas 3.0 motor, a higher torque. If you want a bunch more info on that, and I don't know how much we want to go into today, this is where we tell you to subscribe.
Yeah, we'll have another video soon going through what we're gonna do to try and solve this problem.
Yeah, and we're releasing information as we are fully confident in the information that we're going to release. So
any questions, any comments, anything you
guys
have.
If you guys have questions about this, put them in the comment section. We'll monitor it. Follow us on social media. We're on Instagram. Subscribe here. You'll get updates. And we'll see how this video does. It's our first one. We have a lot of stuff to talk about. And I know that people are going to want to see, I would think, videos like this about our portals. We'll dive into those too. But this rack here got such a reaction on social media, and there was so much speculation of what we are and are not going to do, that we figured we'd throw out a first video, cover a couple topics, and go, this is what we have, these are the failures we see, and then give us a week or so, and we'll release more information on what we are actually doing. Anything else?
Sums it up for this one. I
Cool.
think we're all good.
All right. Thanks, guys.